As I told you on our previous slide, RIP is a distance vector protocol. Routers that are using RIP protocol create their routing table based on information exchanged between routers, and these routers send routing updates each 30 seconds to each other as broadcast for RIP version 1 and as multicast in RIP version 2. RIP uses the Bellman-Ford algorithm, guys, and the actual metric of RIP is the hop count. RIP can support a maximum hop count of 15 routers. For example, as you can see on the screen, if you want to reach from the router 1 to 10.0.0 network, 10.0.0.0 network, the best path will be the path above, because we use just one more hops to get the destination, but for the link below, as you can see in here, we use 2 more hops, which means 2 more routers to get the destination, and which means a worst path for the RIP. That's why we are using this path instead of this path if we are using RIP as a dynamic routing protocol. So let's go ahead with how we can establish a routing table in RIP. In the first stage, all routers install their directly connected networks to the routing table. As you can see, router 1 installs 1041 and 1042. This guy installs the 42 and 3, and this guy installs the 43 and the 44. Then in the next stage, routes are exchanged between neighbors and the routing tables begin to grow. As you can see in here, this guy knows this networks firstly, and router 2 knows about this, and this guy knows about this one. Then they are starting to exchange routes with each other. For example, router 2 says router 1 that, hey router 1, I have a network which is 1043 and that is directly connected to me, which means 0 as hop counts, and router 1 installs this to its routing table. As you can see, the network 104300, and the interface is the fast Ethernet 00, as you can see, and the hop count is 1, because router 2 is saying that, hey, 1043 is directly connected to me. Router 1 gets this update and says that, router 2, if this guy is directly connected to me, if this guy is directly connected to you, I'm sorry, it means 104300 is 1 hop away from me, which is actually you. Okay, then after all routes are exchanged, and as you can see, full routing table is established. For example, router 3 announced this route 44 route to router 2 and told that this guy is directly connected to me, and router 2 installed this as the 1 hop away and advertised this route again to router 1. Router received it and told that, hey router 2, if this route 44 is 1 hop away from you, that means it is 2 hops away from me, and installed it with a hop count of 2. And here is the configuration of the RIP. That's pretty straightforward, guys. and let's go ahead. In router 1, router 2, and router 3, we are configuring RIP in this example. We are typing in the config mode router RIP, as you can see in here. And if we are gonna use the RIP version 2, we are typing the version and the 2, version 2. Then, what you're gonna see in here is, for router 1, we have 2 directly connected networks, and we are writing these guys in classful state. As you know that this is a B class network, this is an A class network, so I'm typing the network statements as the classful states. For example, network 10.0.0.0 for this network, and I'm typing 172.16.0.0 for this network on router 1. And for router 2, the same logic. It's just connected to the 10 networks, as you can see, this guy and this guy. So that's enough that I just type network 10.0.0.0 for this. And for router 3, I'm typing the 10.0.0.0 and the C class of this network. Alright, that's pretty cool. And to verify the RIP configuration, we can use show IP protocols command, and we can display the routing protocol we are using, which is RIP in here, and we can see also the update timers and the invalid and flash and the hold on timers as well. And to verify the RIP configuration, we can also use the show IP route command, and in the routing table, as you can see, we have some entries by the R keyword, which means the RIP. Okay. And if we were to check the router 2's IP routing table by using the show IP route command, we can see the R commands, R keywords in here as well, which is RIP. And for router 2, that's learning this network and this network from these guys. As you can see, I'm learning the 16.0.0 network via 10.42.0.1, which is here, and I'm learning the other network via 10.43.0.3, which is here. Let's go ahead with the RIP-NG. RIP-NG, RIP Next Generation, is an extension of RIP for supporting IP version 6. The maximum hop count, again, we can use in RIP-NG is 15. So let's go ahead how we can configure the RIP-NG in here. To configure the RIP-NG, the first thing we should do on our routers are enabling the IP version 6 routing by typing IP version 6 unicast routing for each router. Then we are getting into the interface modes. Here is the difference from the RIP configuration. In RIP-NG, while we are using RIP Next Generation for IP version 6, we are configuring the IP version 6 statements under the interface modes, as you can see in here. So we are getting into the interface mode by typing for router 1, for example, interface geek 00, and the command we can is pretty straightforward. IP version 6 RIP, a keyword which we can use arbitrarily. This is my RIP for this, and we are typing enable. Okay, that's pretty straightforward, and the same thing for the other interfaces as well. And to verify the RIP-NG configuration, again we can use the show IP version 6 protocols this time, and we can see that the IP version 6 routing protocol and the routing protocol name, as you can see in here, which we configured as my RIP for the previous example. And we can also use the show IP version 6 route command, and we can display our full routing table, and we can see the routes learned by RIP again in here.